And Hans Martin, good morning. Welcome to the stage.
Good morning,
You
Laura.
are indeed the chief expert for virtual prototyping, and at that level, you are the coordinator for sub-project 3, which is model development and usage. We are excited to hear from you. Welcome on stage.
Thank you, Laura. Well, I'm Hans Martin Heindl, and I'm working in the field of systems engineering and simulation for more than 30 years now. And therefore, I know a lot of system engineers and a lot of simulation engineers. And I want to give first a voice to that group. So I will start with the system engineers. Well, I'm a system engineer, and I like structuring, and I structure everything, and even if it makes sense or no sense. And if I'm very honest, I also like processes, and I like to restructure every process. Yes, that's my life. Well, that was the voice of the system engineer. Now we look to the simulation engineer. Oh, what happened? A really red face, and if he has a hat on, it's a head of anger, really red. I'm a simulation engineer. I'm really angry. Well, I want to simulate, I want to solve problems. And every year, new processes, change processes. I have to fill up silly checklists every year more. And I really want to simulate. And perhaps this information is useful for somebody in my company, but for me it's a waste of time. And I'm really angry. My problem is, for example, I'm looking for parameters. I'm not always sure where do they come from. So that's my problems. And I'm really angry now. Well, I think we have to stop now. Well, and in my presentation, I won't try to show that processes, we need processes, that sometimes they are useful, and even for a simulation engineer, if they are well implemented, he gets more benefits out of this than he has to invest. But we will see. So I want to start with the challenges, give a little overview, and the main part is how do we collaborate, especially with partners. So what are the challenges? So in the moment, digitalization and virtualization is increasing. So therefore, we need virtualized validation and release of our products. That means that really the simulation process gets more important. And what's very important, these simulation processes must be integrated into company processes. And that must also be supported that we can cooperate with partners. And a key factor for success is that we efficiently implement these things so they can be easily used by our engineers. And for us, and that is also the reason for our project, we need therefore standardized processes and standards. So what you see here is our so-called simulation process framework. So that process framework, we had discussions with about 20 companies, and they all say, well, that fits. So in our company, it looks slightly different, but in the core, in every company, that fits. And I will explain now a little more in detail. So on the upper level, you see the product development process, and within a product development process, you normally have thousands of decisions. That means design decisions and also release decisions. And for every of these decisions, we have a so-called, if we use more simulation, a simulation-based decision process. That means for every of these tasks, we have to analyze these tasks, we have to say what risk is inside this decision, and to make and define our subtask. And the subtask can, for example, be simulation or also real testing. And on that level, we have to collect the results of the subtask and make the final decision. And what you see here on that level, that is mainly the focus of the public funded project VV methods. And what we were focusing here in that level are more the lower parts, so the credible simulation process, and here we need a clear input and that we can get back a clear output. And the credible simulation process needs also credible models. So we have also sub-processes for modeling, for parameterization. So only as example, here stands the credible modeling process. And you see here, so from the product development process, the application situation is given to the simulation-based decision process, and the simulation task and objectives is given to the credible simulation process, and so on. And what's really important, we need a clear structure, and that we also used within our project here, but we see, and we also did it now, this can easily integrate it in company processes, because company processes to change is very complicated. So we have somehow to guarantee that our processes can easily adapt it and integrate it in specific company processes. And the other point, and that's the really key point here, we need all these informations that if we want to make a decision based on simulation. Now we shrink that one because that framework is only paper, but what can we do with it? And that is the next point. So that framework gives you also a frame for our methods, also the methods we develop within the Z-level project. Because if we have, for example, a validation method, it must be clear where do we use it in the process, what do we need for input, what is the output. And therefore, we use also that simulation framework. And as I said, a process framework is normally only paper. And that it works efficiently, we also need data standards and somehow IT support. And what we already achieved, that we have data formats which are consistent, and we have already tools which support that process. And now to the very important point, because inside a company that often works already. But what's now very important, especially in the field of autonomous driving, we have to work together with partners. So, for example, if an OEM, partner A, is developing an autonomous driving function which is based on a camera signal, and for developing, he needs a camera model. And that he gets the right camera model, he has to give the necessary information, we call it a modeling request, to partner B. So partner B can develop the right model, and the model can come direct from a library, or the model from the library has to be modified, or he has to develop a new model. And what's also very important, the development process, either it's in the library or it's modified, it's nearly or it's the same, because we need some proof of quality from our model. So we have nearly the same row of elements in the process if we are doing a simulation process or if we are developing a model. And then we give the model back. And now what's very important, and that in the moment we analyze it, it's a weak point. So what information do we have to give from partner A to partner B? Because here every company make a different structure, different information, and that's often a problem. And therefore, what we did, so as you see before, the credible simulation process has a clear structuring. And we say, well, we should use that structuring also for the information package. So we have the same basic structure in the simulation request. We need administrative information, we need objectives, and so on. And now I want to go through that chain and look, can we achieve here somehow traceability? So in the beginning, we need the simulation request, which is sent from the partner or within our company to the credible simulation process. And from the simulation process, if we need a model, what information do we need for the credible modeling process? And here we also have recursion. So often people say, well, that is a time scale. No, it's only a logical sequence. So at every part, recursions can occur. And then we get the modeling report back and also the simulation report with the result. And for us, it's very important, and that was also a big and good finding. We need these information packages, and if we structure them in that way, we really make a cooperation better and reduce our effort. And what was very important, that already consistent data formats support that, and they are available. Now, one level deeper. So you see the same picture, but with a little more information. So what you see, if you are working within your company or within your department, you see if you have a camera model and you want to look what are the requirements for the model, what is the design specification, you can look in the row of the credible simulation process, where is that information? But what happens if you work together with a partner in your company or external? So that row of information is broken. And how can we close that broken row? How can we achieve traceability? First, we need the credible modeling process, so the chain is somehow closed. And now came the important points. Up to now, normally, you get paper which specify what are the structure of the model you have to develop, what are the inputs and outputs. And we are using FMI and SSP, so it's possible that you define the outline of the model, also simulatable. And what we also think is a very good, if you have some acceptance test, you should also deliver a simulation environment which contains the environment models, the boundary models, so that partner B can simulate with that infrastructure we send to him. And what we did, we make that package, you see, these elements from analyze, design, and we pack that into the modeling request. And these can, because it's the same structure as I showed before, can then easily integrate it into the infrastructure of partner B. And he will receive also the infrastructure for the acceptance test. And based on that, he can develop the model of the camera, make the acceptance test, pack all that information in the modeling report, and give it back. And what you see now, that is what we understand under traceability, and what's very important, that must be supported by tools, by data structures, by data standards. Otherwise, it's a lot of effort. And that's the way we think we can make traceability available in a way that we can really use it. So, now to the summary. I think we need the use of simulation for the development and for the release of automated driving functions. And with the credible simulation process framework, we have now a framework which supports the traceability, which can be integrated in all companies, and that's for me the most important point, that supports the collaborative development with partners. And the proof of concept we did in the use cases, which were shown here, and with a workshop. So we made couples with an OEM, with suppliers, and we had 4 couples, and we played through these processes, and we said, well, that is exactly what we need, so that proof of concept is already done. And what's very important, consistent data formats and tool support is also and already available. And now to the takeaways. So the work results are available on our intranet or the web pages. And also the big and important point, because what happens after the end of this project? So the dissemination and the maintenance of the credible simulation project is guaranteed, is further developed by the ProStep Smart SE project, and it's already used in other public funded projects like the ITA East project UpSim. UpSim stands for Unless the Potential of Simulation Projects. And the data formats like SSP Traceability, STMD, SRMD are hosted by the Modelica SSP project. Well, that was my talk, and now we can look to the simulation engineer. Well, the red hat and really changed from deep red, not to deep green, but slightly green. So I think we have achieved a little good result. Thanks a lot.